And we'll switch to English now because we say welcome to our show, SPRIND founding director Rafael Laguna de la Vera. Welcome.
Well, thanks for having me.
Thank you for being with us. So let's just dive straight into it. Why does any given country, whether it's Germany, the Netherlands, or any other nation, need an institute for breakthrough innovation?
Well, because obviously we did not do a very good job in the past 30, 40 years of translating scientific innovation into new industries, with few exceptions. I mean, the Netherlands obviously has ASML, which we'll probably talk about a bit more, and maybe Germany has BioNTech, but really that's about it. If you look at where all these new industries were created, it's been outside of Europe.
Yeah, so you managed to set up SPRIND about 7 years ago. How did you go about that to realize it in Germany?
How much time we got?
Well, take us along the gist of it.
Okay. Well, I'm an entrepreneur. I'm a software person. I'm an investor person. I'm not a government person to begin with. So the first thing I had to learn is how government functions and how you build a government agency, which was quite an experience. Then number two, you have to set it up such that you can actually be useful and make it work and have all the features that an innovation agency needs, like for example, agility and speed, the ability to take risk and fail, all words that are quite foreign to ministries. So we had to sort of define ourselves, free ourselves, explain ourselves, that we need to do this differently for it to work. And in parallel, you need to start working because people want to see results. So we not only designed ourselves and pushed for law that freed us from a lot of the shackles, but also we started our first challenges already a year into launching the agency.
Yeah.
Well, and then you just plow on. You just do things and show the results. Interact with the scientific community, with the government community, and make sure that you're creating success.
Yeah, and in terms of actually getting that green light, what was key to convincing the government at the time that this was needed and actually got started? Because we're still in the is this going to happen or not? And to what scale phase in the Netherlands? Reflect on how that happened back in the day with SPRIND.
What actually today marks the 20th birthday of a commission that's called the Expert Commission for Technology and Innovation, or Research and Innovation, EFI in Germany. Mm-hmm. Which has been incepted in 2007-8 to consult the government on where to invest in terms of research and innovation. And one of the recommendations in 2016 was to build what was then called an ARPA or DARPA-like agency for Germany.
Yes.
Because obviously this gap was recognized, the translation of scientific breakthrough into industries. And the market failed it. So there was no private investments that did this. So it's a gap, market fails, government needs to step in. That recommendation was taken very seriously by the then Chancellor Merkel. And she put it into the coalition agreement like the Netherlands did, and put it into action in 2017. And then in 2019, there was a founding commission. It took 2 years. The Netherlands has been much faster. The founding commission is already almost done, you can say. Mm-hmm. And then we launched the agency in 2020. So we made it real, and that was...
Can you explain one thing for me? A DARPA or a SPRIND is for the first, the innovation, to bring the first innovations to life. But you talk about to bring the innovations to the industry. And in my opinion, that's the next phase. So where are you in the phase of a new company, of a new innovation?
That's a very good question, because we often say we build ARPA-like agencies. When I looked at what ARPA was doing, I realized that this was not the gap that we were having in Germany or in Europe, which is applied basic research.
Yes.
We have great basic research. Yep. So DARPA is funding applied basic research, which you can express in so-called technology readiness levels. Mm-hmm. So basic research is TRL, technology readiness level 0 to 2. Yeah. Right? This is in the lab. You haven't proven the physics yet or whatever it is, right? And then you start building a prototype and it looks like it might be real. The science works. That's then TRL 3 and on. And this is where we step in. So we want to see a prototype. We want to see the science to be proven. But now we want to make this prototypes into an industry. to make a very long story short. And this means we're starting where DARPA and ARPA usually stops.
Yeah.
And actually DARPA and ARPA and all the other ARPAs envy us for our ability that we're able to follow on after the basic research and help this evolve into a producible product that actually gets into the market and that the private financing sector picks up, because that same valley of death, as we call it, after basic research is also something that the US has. And even though they're quite successful with some technologies, they're not so successful when you look at very hardcore deep tech stuff.
Yeah. Now, we should stress that SPRIND isn't exactly the same as DARPA or ARPA because, well, the US agency was primarily focused on technology for military and defense purposes. As I read, that SPRIND is very much focused on civil, as you say it, sprunginnovationen. What does that mean for your activities specifically compared to, for instance, DARPA then?
I mean, actually, this is not so much a differentiator. It's just a political accident. I don't think that a SPRIND or a NADI should, differentiate between civil and military. There's a lot of dual-use things.
Right.
So, for example, we've seen thousands of projects. We funded, I don't know what the number is currently, maybe 350 or so.
Right.
And 80% of them have a dual-use application. Now, that's one, right? So you can say, okay, we've been in the past, because that was the political decision, focusing on civil applications, which is great. But then Ukraine happened and Trump happened, and suddenly things are going a little bit differently. And suddenly all we peaceful Europeans like military applications again. So or are forced to like. So nowadays I would say it should be one thing. Right.
So, okay, defense or not aside, or dual use for that matter. Does that also mean you and you alone as SPRIND get to decide which innovations should get the green light and thus make sure they get the opportunities and the funding to grow? Is that your sovereign call to make?
Yeah, and that sounds kind of wild when you think of it. Yes, that is part of the freedom that you need to give these agencies. And actually the DARPAs have that too. There's, of course, always a strategic meetings with the government, where the government explains what the focus areas of their work are going to be. And if there is an overlap, if we think the same way, or if we can help them make the strategy real and we like it, like, for example, with nuclear fusion in Germany, we've been working on creating a government strategy for nuclear fusion or for chips and so forth. And then you make these things align. And then you're actually doing stuff that the government likes you doing. But also the opposite is true sometimes. Governments change their minds a little bit too quickly back and forth, whether they like certain technologies or they don't.
Can you give an example of that? How they changed in the past?
Nuclear fission is a good example.
Yeah, that's a good. Yeah, I think so.
Right. So we like everything nuclear. We like nuclear fusion. We like nuclear fission. We like transmutation, and that's a very real example. Transmutation is not regarded as something that should be done in Germany, but transmutation is a technology that can deal with all the fission garbage that you have. That this stuff is highly radioactive, that we haven't found a solution how to bury them for 1 million years because there is probably no solution. Transmutation can help you turn that waste into something that actually is useful again. It's again fuel for fission, but it's also isotopes for medical applications, which are very scarce and very expensive. And it gets away with 90% of the waste, and that waste only needs to be buried for 1,000 years, which is a huge difference to 1 million years. But transmutation is currently not regarded as something that should be researched in Germany. We're doing it anyway, and there will come a time
that you convince them
that this will suddenly become en vogue again because things change. Same as for nuclear fusion. That wasn't a big thing 6 years ago when we started at SPRIND. We invested anyway, and now it's a huge thing in a government strategy.
Yeah, can you tell something about the criteria that you go on? Because you said there's a group of people who will not decide, well, we'll go on or not.
The
commission, there are milestones. What are the criteria?
First of all, let's talk about the people a bit, because that is the
always the most important thing.
Yeah. Always. It stands and falls with the people. So the critical people at SPRIND are what we call innovation managers. DARPA calls them program managers. ARIA in the UK calls them program directors. Call it what you want. These people usually have a scientific background, have been successful in building companies, taking them public or selling them, and have sort of lived their commercial lives, but have a couple of ideas what else needs to happen to change the world for the better. So people that are, first of all, very experienced in what they're doing, but the fire is still burning. Right? They don't want to drink rosé in Mallorca from 11 on every day of the week, but instead, they want to fix the problem, the big questions of our time. That's a typical innovation manager that we're looking for. So you have very trustworthy people with no personal interest in making money and funding their company or anything like that, but instead, tackling the really hard nuts to crack. That's what they want to go for. And now you've got to give them a platform and the freedom and the power to do their thing. Number two, of course, we have created a catalog of criteria that we're looking at when we're looking at projects that we're getting. And again, people is one of the 7 categories in there. Who are the innovators in this group? But of course, it's also how's the science doing, right? Is this real, or is it a perpetuum mobile that cannot work, right? There are some physics laws that we need to believe in. You don't need to stretch it too far. Sometimes science changes, right? And you learn new things, but some things are quite stable and you can filter those things out. The second is it actually transformable? Can we turn it into an industry? Because some say, we just need to change the overall infrastructure of roads and then this thing can, will fix
change all the roads. Good luck.
Good luck. Never going to happen. So no, unrealistic. We're not going to do this. Do we have enough money to do this? Is there an industry backing this? Can we translate this into something that can be backed by existing industry so that we can scale very rapidly? 80, 90 of these criteria are being researched for every of these projects so that we have some kind of structure. But in the end, it's the innovation managers, the analysts, and a very small board that makes the investment decisions. It's either 2 or 4 innovation managers. It's myself and my colleague Berit, so the CEOs of the agency, and that's it. We make the decisions for funding.
Yeah. So what was interesting when I read it, 250 million was the total, and the teams you have, they don't get so much money. It's 1 million or 2 million. It's quite a lot of initiatives, but it's small. I thought you had 2,200 initiatives, and there are gone now, of course. So why that approach? Why so? Okay, sometimes they need a lot of money because hiring people is really expensive nowadays when you're really good. And the computer is expensive, the models are expensive when you work with AI, but also with Fusion. It's also expensive. Why such a small teams?
Well, the one thing is the money that we are consuming for the agency, for ourselves, right? That should be very small because that's the overhead. Right? Also, the innovation managers don't work for SPRIND because of the money. They're in the wrong place. They're not working if they're looking for high salaries or something, right? Not going to happen. No pensions. We're not forever. We're not Beamte, right? We're not forever state employees. None of that. Number 2, all our programs are very efficient and slim. Like challenges need a preparation of maybe 2 or 3 months. The call phase is 4-6 weeks. When you're invited to pitch in front of the jury, the next day you have your decision and your money. So that's 14 days between you proposing your project and you getting the money. Time to money is the critical factor. That not only keeps the cost down, but also makes us very fast. We've launched more than 20 challenges with a small team. Now, all the money that we're spending goes into the teams, but we're also leveraging this money with private investments and other funding sources. So right now our factor is about 3 times. So for every euro we put into a company, another 3 go in. That number will go up significantly because since the SPRIND Liberty Law, the law that I was mentioning in the beginning, we're able to co-invest with the private sector. We've done about 40 of such investments in the 2 years that we're now able to do that. And the multiple of money that we're getting in is much, much higher for those investments. So the average, we already know that, will go up. My goal is to get to 20 X for every euro that we're investing.
Yeah. Since you mentioned that law, I believe that was integrated in 2023, I believe. So you were able to work in the way you just described. So important sidestep here, and also reflecting what you said earlier. You're exempt from regular government budgeting, able to make your own choices. But what does happen if there is a clash of perspective or interest in that sense? How do you maintain that sovereignty? Or is there, like, suddenly you get a text for a cup of coffee with someone higher up from the government?
Well, first of all, we're not that independent from the budgeting process of the government, because what we have not accomplished yet, and what we're highly recommending to all the new agencies, is a multi-year budget. SPRIND does not have that. We're proposing it for NADI. Vinnova, for example, in Sweden has it. ARIA has it. We don't have it. And we don't have it yet. We're still fighting for it. So for every year, every next year, we have to fight for our budget.
Right.
So far, we've been successful in growing it from zero, obviously, when we started, towards about 350 million this year, 220 of which comes from the Ministry of Research and Technology. And then there are other ministries that we're now working with, Ministry of Health, the Digital Ministry, the Ministry of Economy, that now provide us funding for things that we're doing, which are sort of aligned with their interests. And that's great. We don't have €1 yet from defense, which is kind of wild, because you may know that the defense budget goes from 50 to 130 billion a year.
Yeah. I was going to say, there's some interesting shares to divide there.
Well, we're working on it. Nothing goes fast when you have a government interface. That's what ministries are built for, to slow down things, right? And sometimes for good reasons, and sometimes maybe not. And maybe we talk about this intrinsic conflict. So one thing you have to be aware of is that you have to fight for every item of freedom to A, get it, and to B, keep it. Yeah. Because the system wants to take it away with 1,000 small cuts, from which you will eventually die if you don't fight these 1,000 small cuts. So, so we have to set it up as good as you can, right? Yeah. You're taking away power from people that are used to have power, like the people deciding on the government budget. It's parliamentary people, the household people, right? They have a lot of power over the ministries. Now, if an agency like us gets their money for 5 years or something like that, only every 5 years they can somehow influence the process, right? Yeah. Which they don't like very much, obviously, right? Because you're taking away power. But I think it's a prerequisite for that, all these things that we discussed before, and the amount of freedom that such an agency needs is, of course, defined through the money. Money talking, bullshit walking.
Yeah. But Rafael, if I can push you there, what would you say is key to convincing the government people who are, able to direct that, usually to let go that share of power? And additionally, since you are trying to get this recommended with the formation of NADI as well, what kind of budget in this day and age will be required to actually make an impact?
Well, I think the political decision needs to be that we need to try whether this works for us or not. And if you do a trial, do it right. Don't make it half-baked.
There we go.
So if you want to try NADI, give it all the freedoms, give it at least 5 years of budget, and another 5 commitment after that. Mm-hmm. Because you need 10 years to show whether you're performing or not. We are now our 7th year. We can now show our first unicorns that we helped create. Mm-hmm. Right? We show that huge strategies like the chip strategy, the fusion strategy, and many others are working. We show that a couple of projects are so well advanced that they might actually work, right? Because we're getting close to where this will be proven. And in 3 years, it will be proven. In 3 years, we will have 10 unicorns or 20, what do I know, right? We will have maybe a potion against Alzheimer's out there, right? And a few cancers are curable because of our work. So this is then done, right? Yeah. But you have to try it, and you have to try it for real and not half-baked, like I said before.
Okay. And can you name a number? What budget should we be striving for?
Yeah, if you look at the US, they have a bunch of ARPAs, DARPA, ARPA Health, ARPA Energy, and so forth. And then you compare it to population size or GDP, which gets you sort of in the same region. For Germany, I can say SPRINT's budget for civil work should be 1.2 billion euros per year. And for military work, at least 2 billion. a year.
Yet
Now,
you are getting 250 million, but carry on.
The 350.
350, there we go. Go on.
350. Yeah, we're at a tenth of what we're shooting for. Right?
Okay.
But then we're breaking ground, right? We're the ones that started first in Europe, and now we're breaking ground for the others. Now, if you translate that to Holland, and you say Holland is about 22% or 25% or 20% of Germany, depending on what number you're looking at, you get to the number that Wenig once said, which is about 1.8 to 2.2 billion a year.
Okay,
right?
yeah.
So you can't start with that number, right? I mean, that's way too high. I mean, you have to grow the organization first.
Yes.
So my recommendation would be start with maybe $500 million or $1 billion for the next 5 years. Right, and then scale it up.
Okay.
Yeah, so that would be $500 million for 5 years, or half
1
a billion,
go for 1 billion,
or 1 billion, or per year.
No. You have to go from zero, right? SPRIND started in 2020. Our budget then was, I don't know, a few $100,000. Then we went to 20 million, 40 million, 80 million, 160, 250, 350. We can scale faster now, and NADI can scale faster than that. So if you say $1 billion for 5 years, you will have like 400 million or so in the fifth year, and in the first year you have 20 or 50 or 100 or
go up
whatever.
in steps.
Yeah. Right.
Okay. In my opinion, that's not so much money when I look at all the money in the world, and then we are discussing $1 billion in a year. But okay. But in the Netherlands, people are sometimes oh yeah, what are you doing with the money? And I don't like it. How do you manage the general population that sometimes you waste money? How do you manage that? Because
the risks are inherent.
The risks are inherent that something goes wrong. How do you manage that?
Well, a lot of explaining. We actually spent a lot of money on marketing. I'm doing interviews a lot. Right?
Tell us, Rafael. We rely on your experience and wisdom.
No. You have to explain yourself. You have to explain that innovation needs some kind of risk taking and chaos. Actually, the Nobel Prizes for Economy went to 3 people that explained this very scientifically, that if you want innovation, you cannot predict innovation, because then it's not innovation. If you know beforehand, it's not an innovation. Right?
Exactly.
So you need to take risks that these things might fail, because if you don't do that, you're not investing into innovation. Right? This is innovation theater. You're doing like it is innovation, but it's not, because you're proposing something that you already know. And a lot of the scientific funding works that way, unfortunately, because to get money for 3 or 5 years, you have to explain what you're going to do in the next 3 and 5 years. You don't know that. If you're really innovative, you don't know, right? So what we're saying is we have all these parameters. We check whether the science can work, whether the people are great, and what have you, whether the money is sufficient that we can provide. And then we look at the results. We're results-oriented. We see what comes out of that. And we're not process-oriented.
Exactly.
We're not looking at the paperwork. We're looking at the results. And then the other thing you need to explain is, out of the hundreds that we're financing, 5 need to work, or 10.
Yeah.
This will pay the whole check. This is called portfolio strategy. This is what venture capital does, right? And this is what you need to do in innovation financing.
Yeah, can you give an example that was a failure and that you didn't expect and you had to explain? And then we go to a success of the 5, of course. But first, the failure and how that went.
Yeah. The way. Let me explain how we build failure into the system that we're using.
Okay.
For challenges, when we make a call, we say we want to solve a huge question of the time, like cure viral infections. Yeah. Right, so that we don't get another corona, or long-term energy storage, very cheap and very ecological, right? Or drone defense, right? Get down the drones without shooting at them.
Drone defense, without example, I think.
Right, and especially non-kinetic, because you cannot use kinetic drone defense in the civil landscape. When you're not at war. So very difficult questions. We get between 50 and 500 proposals of teams, which the jury, which is an external jury plus an innovation manager, scans with help of AI, of course, and then we select maybe 20 or so and invite them to the pitch day. Well, pitch days is usually 2 days, right? And then 10 teams get selected, and we give them a lot of money. They start working, and then a couple of months later, they come back and show their results, and we fire 40% of the teams. 60% can continue. So you might say these 40 have failed because they don't get the second step funding from the challenge. But more often than not, these guys get money from elsewhere because they're still pretty good. They're just not the best. So now, and then you rinse and repeat. And usually we have 2, 3, 4 winning teams that get all the way through. And then they get project funding, which we can scale from 200K at the lowest level to tens of millions, to make them sort of ready for investors so that private investors can carry the projects on. Now, if you're failing less and less the later the stages, so your failures are somewhat cheap.
Yep.
You know, you may be wasting 200K or maybe $1 million. Many will say $1 million is not cheap. Well, you know, if you look at investment activity, well, you know, when they're at the later stages, they only get the money, the 20, the 50, the 100 million, if they're really close to being successful.
And in that system, the visibility of a failure is less because you are failing with the other ones that you're not going to the next round.
Yeah.
So that's a good method.
Yeah. So how do you then ensure you deliver innovations to the doorstep of commercial investors, but also in the process before that you complement existing institutes? Because obviously there are technical universities, there are R&D labs and major companies. How do you tie in everything in the ecosystem to make sure it works efficiently and not does things in multitudes?
We are first of all, we are a fresh breath of air for these guys. All the scientific institutions, research institutes, but even small companies and large companies, when they start interacting with SPRIND, they go like, wow, you're easy to deal with. You don't feel like a government agency, right? You have people that really want to help us. You know, you're treating us like friends and not like something that wants money from us. So that is, I think, the most important way of building sort of a trust system which works both ways. Then number 2, of course, we are very strict when it comes to the results that we want to see. So this love ends sometimes very abruptly when we say, sorry, but this is just not good enough and we have others that are better. But this creates some sort of elite exclusivity for the teams that make it through several steps of SPRIND funding, which makes them super attractive for the private financing sector, because these people say, wow, they went through the SPRIND school and they survived it and they're still around, right? So they must be pretty good. They must be the best of the best. And that actually is reflected in our annual investors conference, which grew from 20 investors showing up to 40 to 400 this April, 400 international investors showing up for 120, 130 teams.
And now we want to hear the success story.
Well, you just mentioned you're delivering the first unicorn.
Exactly.
Now, if I understand correctly.
Yes. I mean and that's a very good story, because back in 2020 and 21, we were always writing down long-term strategies for the fields that we want to play on. So we wrote down the fusion strategy, and we realized that plasma fusion is pretty advanced in Germany, because we have a research plasma fusion site called Wendelstein, which uses a stellarator technology. That's great. But then we're also pretty good in lasers and mirrors. Right? You know that
mirrors,
the lasers.
Yes. So we should mention science here.
Right? ASML,
yes.
Lasers from Trumpf in
They're
Germany, mirrors from Zeiss, right?
Yep.
We're really good at this stuff, right? And there's others like Thales and so forth. So we said, no, we should also try laser-based fusion. So we said, we put our first money down on lasers, on fusion-capable lasers. Unfortunately, they're very expensive, so we had to put down 90 million euros for those, and we're building them. That decision was made in 21. We're building them for 2 of the laser fusion startups, Marvel Fusion and Focused Energy. We communicated obviously the fusion strategy, talked to the scientific community. Some even didn't like it because they thought plasma was the way to go, because we already have Wendelstein, and why should we bother with lasers? Now, to shorten the story, now the government has a high-tech agenda for Germany, and one of the 6 pillars is that we want to build the first fusion power plant in Germany, which can either be laser or plasma, and we keep it open. We keep it a race between currently 4 companies, 2 plasma, 2 lasers, and billions will be poured into this. We're working with the large industries, the utility company like RWE, which is a producer of electricity. You know that we have these old fission sites, nuclear fission sites that are now defunct. So we're rebirthing them into fusion sites and sites for the industry to build the lasers and mirrors and magnets and everything that we need. And of the 4 companies, one is already officially a unicorn with a 2.5 billion euro valuation, Proxima Fusion. The other one, Focused Energy, is well on their way to become that. So this is why I'm so confident that we will have a bunch of unicorns in a very short time frame. And then there is Marvel Fusion and Gauss Fusion, and I'm sure they will be unicorns next year as well. And if you look at how this is being regarded from the international industry, like the Americans and the Chinese, they are taking us very seriously when it comes to fusion, which is not the case for many other technology fields.
No, I imagine, but that's the thing. What springs to mind for me is how advanced the Netherlands is in terms of quantum computing, for instance. It's also a field we're highly regarded in. Yet at the same time, and I'm also looping back to Ben's remark just now in the way it's perceived, especially when I listen to the reports in Dutch media about how Germany is doing in terms of innovation, also legacy industries. For instance, the automotive players struggling against competition from China. The fact that in terms of frontier AI, Germany may not be showing all that much. How can you counter-argument all those reports with what you're delivering?
Well, first of all, don't drink the wrong poison. Don't believe them. I mean,
please enlighten us so I can reflect as well whenever we're talking about it.
All this down talking of Europe is driven by forces that don't like us, that want to destroy us. You know, and that's all I say.
But even
about
tech
this.
entrepreneurs in Europe are saying it, obviously as a means of trying to accelerate something, to make something happen. But it's not the optimism you are radiating, at least.
No, and I don't like people doing that. First of all, you know, there's a sticker on my Bosch painting behind me that says "Pessimism is a waste of time."
I agree.
Right? All right, and we're distributing T-shirts that has that on there. All these people that are complaining about the bureaucracy and what have you, and all these bad things in Europe, and this is why we're dead. They have some mission that is not my mission. If I look at, for example, let's take Frontier AI.
Right.
We launched the Next Frontier AI Challenge with 125 million. This is our biggest challenge so far. We got 530 proposals out of Europe. Challenges are always European. We never limit them to Germany.
Right.
We filtered it down to 50 and then to 20. The 20 pitched, and then we filtered it down to 10. And the first 10 teams got their money. It's 3 Germans. It's, I think, 2 from the UK, 1 France, and so forth. So it's and these teams are world class. I mean, they are world class. One team actually has a very, very famous US investor already, venture investor, which I know very well. They're good people. Investors are very good people. So they have recognized the capabilities that we're having here. It is the toughest race. AI is currently the toughest race that I can imagine. But there will be a lot of leapfrogging inventions that change the whole marketplace big time. So the current stars that we're seeing, like Anthropic or so, they may be gone in a couple of years because somebody develops an algorithm that consumes a millionth of the power. Right? That is, whatever. We know it works because we carry it in our heads. This is a computer that consumes 20 watts. Right. It's quite intelligent, right? So we don't need 20 gigawatts to run the new data centers. These things will happen, and if you look at the teams, you're convinced that there is enough talent here. And if you look at the teams of those Americans, you'll see that a lot of Europeans are working for them.
Yeah, and I know quite some are heading back to Europe over the past 18 months-ish.
Yeah, for good reasons, right?
Yeah.
Europe. I think Europe has a huge opportunity because we have a humanistic foundation that's quite stable. Right?
Yes.
A Trump would just not work here, and people recognize that this is beneficiary. Now, I'm talking about AI. I told you we saw 5,000 projects or whatever. We've done more than 20 challenges. We've financed 350 of them. those were maybe 10 teams of the 350 that I'm talking about. Now go to life science. I mentioned Alzheimer's. We actually have 2 very promising projects for Alzheimer's. Different kinds of cancers, even a cancer vaccination that avoids relapse of cancers. And you saw, I think today, that Moderna's clinical 3 trial was successful for various cancers in mRNA technology, which was funded by DARPA, by the way, 20 years ago. Right?
Well, there we go.
So there we go. And that's what we do. And there is CRISPR, there's DNA origami, there's so many new technologies in life sciences. And you see these people doing this, and you see what they're doing. You're actually talking to patients which were dead, dead men walking, because they were, their therapy was not successful. They had some kind of terrible cancer. So you can do an experimental trial with your potion, and these people are healed. Right? This is quite real, right? This is really real and very touching, and this makes you an optimist.
Yeah, great. My last question. We talk a lot about science, and you already mentioned your painting behind your back from Jeroen Bosch. You also mentioned earlier to us that you like Escher, also an artist. How do you implement art into a lot of science? And Steve Jobs, art and science is the combination. But how do you implement the art part in your
method?
Yeah, method.
That's very, very good. The reason I decided that I dropped my investment and company founding life and do this was that I felt that I was able to do things that art predicted, and only art can do this. If it's science fiction books, it's paintings. It's often people that do understand a lot about technology, but have the ability to free themselves from the limitations of the normal technology thinking.
And to be inspired.
And to be inspired and inspiring. I mean, if you look at, Neuromancer, for example, William Gibson. How old is this book? 35 years or something like that? Mm-hmm. Right? And look at what he's predicting. Or listen to David Bowie when he talks about the internet in '99, right? Yep. And then look at Escher, look at Bosch and these guys, and you go like, wow, these people had the ability to distill something into one painting, one book, one song, one interview that sort of predicted the future. I mean, look at Arthur C. Clarke, what he predicted, right? Philip K. Dick and these people. It's just that's been sort of inspiring to me, and this gives you the ability to believe in some of the more crazy things that we're seeing, because if we see there is really no reason in physics or so that this might not be possible, like fusion on a chip is a project that we saw. It's probably one of the most crazy ones that is real, because you can't say the physics could work. It probably needs 3 breakthroughs to work in serious. But if this works, right, you have a fusion chip, that generates huge amounts of energy and is very small, which is wild. And these things are predicted in the works that I mentioned before, and you have to free yourself and give yourself the ability to open your mind to allow these thoughts. Yeah.
Now I have a last question as well. It's even more serious because, say we get NADI across the line in the Netherlands. It starts. It happens. Obviously, there's SPRIND in other European countries as well. How then do we all cooperate in Europe and maybe beyond to strengthen innovation in this part of the world and to ensure we get a better position, if you will, in the technology race against the US and China?
Yeah, I think that's very easy, and we're doing it already. You mentioned other countries, like we're doing the drone defense challenge together with Vinnova in Sweden. Right. And Vinnova has adopted the challenge format. We've been breaking ground also in terms of European law on how you do this, right? And so it works, and now we can work together. So Vinnova put some chips in, sent people over for the jury, learning the format. The same thing we want to do with NADI. As soon as it got its first money, we'll do a challenge together. And we're eager to do it. We already know the topic or two, right? We should just go and start. Same for France. As soon as France is starting their agence de rupture, which is even better, right?
Yeah, sounds romantic.
It's kind of Boshy, right? Rupture, rupture. Yeah. we'll do the same. And we're working on projects with the Spanish Innovation Agency. We're helping the Swiss to build a military innovation agency. We're going to use the Swedish military for military testing of some of our dual-use projects. This European collaboration works. And let's not forget, all the SPRIND challenges, all the more than 20 that we've done, had been pan-European challenges. It is always European. We're always addressing all teams in Europe, plus UK, plus Switzerland, sometimes Israel, Canada, Japan, depending on the topic. So it's very compatible. Now, for example, we launched a challenge, a huge challenge for recycling of electronics together with the National Science Foundation in the US. We put down 50 million, they put down 50 million. Right, they're targeting teams in the US, we're targeting teams in Europe. We have the same jury for both sides, and we're exchanging people and knowledge between the two sides. So even with the US, this collaboration is possible, but of course we should focus on the European collaboration. So seeing these other European sprints coming about, and I'm deliberately saying sprints because we're not ARPAs, right? We're not applied basic research, we're translation, right? Come into existence. Also, I think paves the road for sort of a European version of this which then co-funds the projects of the national agencies. And I think every nation should have such an agency.
Yeah, and let's make an agreement here that whenever that first challenge hits, we'll be there to talk about it.
All right, looking forward to it. Those challenges are real fun. I mean, trust me.
Well, we're looking forward to be a part of it. Thank you so much for our conversation. SPRIND Founding Director Rafael Laguna de la Vera.